come to the last part of this sections of lecture for intensity. The next part is actually the inverse square law. The inverse square law is actually a means, a formula in which we have derived to help us estimate how what is the intensity of a sound at a particular distance away. Now, if we measure, say, if we measure the intensity of the sound coming off from a guitar at 5 meter, all right, we can predict or we can estimate rather the intensity of the sound, say, at 20 meters. So, given the fact that we cannot just uh, make use of this, we can also make a cumulative calculation such as, say, given one guitar producing a sound intensity of 60 decibel at 5 meter distance. Now, what would be the combined loudness if I have 10 guitars, 10 similar guitars performing? And with that, I want to estimate whether is 10 guitars sufficient to produce a sound that can hear across a auditorium of say 25 meters at the back. So all this can be predicted or can be estimated rather by scientific calculations. So as we start here, the inverse square laws in physics is a new physical laws stating the physical quantity and strength that is inversely proportional to the square of the distance from the source. Don't worry about that, I'll come to that in a short while. So whenever energy passes through an inner surface, we must have exact the same amount crossing the outer surface or later. Then because just like a balloon, as we blow up the balloon, as the wave spreads, okay, the outer surface gets bigger for the same total amount of energy. That's why the sound tint off. Now, before we start off, we will need a little bit of math to prove this inverse square laws. And by proving this inverse square laws, I hope you can understand how this whole thing is being derived. Now, before we start, we need to understand what is the formula for a surface area of a sphere. The surface area is 4 pi r squared, not 4 over 3 pi r cubed. That is for the volume of the sphere. The volume of the sphere is 4 over 3 pi r cubed. But the surface area of a sphere is 4 pi r squared. Okay, now, so assuming that someone is producing a sound at a rate of, say, for 10 watts, assuming 10 watts, okay, or rather, these things, yes. So what happened here is, at say 1 meter, the intensity of at 1 meter, this 10 watt would be what? Would be 10 over 4 pi r squared, okay, watt per meter square. Okay, can, all right, stay here. Now, say for example, the total power of that is produced here is P. Okay, and we know that P is actually intensity over area. Okay, so this is what we have covered so far. Now, assuming that we have a radius R1 here, the intensity is I1. So the power is equals to, oh, I'm sorry, I made a mistake here, so sorry. The intensity is equals to power over area. So therefore, power is equals to intensity multiplied by area. Okay, pardon me for that. So which means that at I1, power is equals to power is equals to I1 times 4 pi R1 squared. Okay, now remember why is because at other distance r, the total amount of space covered by radius 1 is 4 pi r1 squared. That's how much surface area is going to cover. Now next, what happens if it's at radius 2? Well, here is radius 2. You cover even a greater amount of space. Whoa, okay, so sorry for that. Okay, you cover even bigger area of space, which is R2. So power is I2 times 4 pi R2 squared. Now the two power here must be the same because the amount of power transmitting across any surface must be the same for energy to be conserved. So rewriting this, we would taking this divide by this, we will have power 1 over power 2 is equals to, or power 1 power 2. Okay, so because of this thing, I'm going to put in a new one. So remember, its power is equals to I1 times 4 pi R1 squared. Power 2 is equals to I2 4 pi R2 squared. Now, because of conservations of energy, which you learned earlier, the power that's transmitting across any through the surface must be the same. So therefore P1 equals to P2. Okay, that means I1 times 4 pi R1 square must be equals to I2 times 4 pi R2 square. Now the 4 pi and 4 pi can be cancelled. Right, the 4 pi and 4 pi can be cancelled. Alright, leaving us with I1 over I2, okay, is equals to R2 over R1 whole thing squared. Note that this is also in terms of exponential. This is the inverse square law, which means it's a given an intensity somewhere at a particular distance. I can estimate the new intensity at a particular distance. So if I know this variable, I definitely will know this I1. So this is what the inverse square laws means. Okay, so let's take a look at the thing. So the energy that passes through 1 meter square of inner surface must be spread out over 4 meters square because it is in terms of a sphere. As the sphere grows bigger and bigger and bigger, as the sound spreads bigger and bigger. Alright, so the intensity must be 1/4 as large. Remember, for 1 meter increase of radius, the area is increased by a square. Okay, so it is also an exponential increase. So given this, I2 over I1 is equal to R1 over R2 squares. Okay, or rather if we take logarithm across both sides, you'll get SL2 minus SL1 is equal to 20 log R1 over R2. Okay, so this is the um, difference in the how we find the SIL given the two ratio values. Okay, so then next, what happens if two source, alright, combine to create a sound? Simply adding intensity to each sound will make a load and get the intensity of the combined sound. Now this is quite easy in the sense that considering a flute that's playing at 60 dB, another one, a clarinet playing at 63 dB. What is the combined dB between these two? Alright, so we will not try to use this intensity to do this ratio method to do. It's highly inaccurate. Okay, let's try not to use this thing. Let's use another method to do the thing by using a more accurate mathematical formula. Okay, so very simple, clarinet 63 dB and a B3 SIL is okay. Consider for playing a G5 and a clarinet. So the SIL is 63 and 60. Okay, the flute is 60, the clarinet is 63. All right. Okay, clarinet and the flute is 60 dB. Okay, all these are 60 dB. What's the combined loudness? Now, do not add dB decibels. Why? If you add two together, you get 123 decibel, which means to say what? It is louder than the jet engine. Is that possible? That is not possible. In order to combine loudness, alright, do not add dB. Add intensity instead. So you need to know how to add intensity. So very simple. What we do is we have to convert. The step is convert dB to intensity. Second, add intensity. Then what? Convert back to dB. Okay, let's see how this thing is done here. Now dB is equals to 10 log 10 I over I naught, where I naught is equal to 10 to the power of minus 12. I equal to 1 and this is 10 to the power of 12. Okay, so let's bring things down so we get equal to 10. And then we invert what 10 Now this is for the intensity of the so similarly, working out on this thing, we will know that IF is equal to 10 to the power of minus 6. Combine intensity is equal to 10 to the power of minus 5.7 plus 10 to the power of minus 6. Okay, we take this combine and then we get the decimal. Alright, this is 10 log 10, a combined one which is 10 calculate it out. Okay, just let me do a little bit of calculation down here. Cancel and 10 to the power of 5.7 negative plus 10 to the power of 6 negative is equals to so much, and then we divide by 10 to the power of 12 negative. Okay, and then we log 10 and then times 10. That will give us 64.76 dB. So it's about 64 point. Okay, I'll just put 6.76 dB. Okay, I can just use 64.8 dB. So this is the answer when you want to combine loudness. Now you can combine 1, 2, 3, 4 loudness. It doesn't matter. Okay, so it works this way. Alright, so now matters become more complicated when we consider two sources frequency are the same or nearly the same or whatsoever. Okay, the continuous ebb and flow of multiple beats when three or more instruments play in unison is called a chorus effect. Having several instruments play together does not merely produce louder sound, it also changes the quality of sound, okay, which is the timbre. So the long-term average intensity is the sum of the separate intensity, the same as if the frequency has been quite different. Okay, so we can just combine the sound in this manner. So in summary, intensity means the rate of flow of sound, okay, and is proportional to the squares of amplitude. So every additional increase of dB represents about 1.3 times. So a sound level of 0 dB simply means it's 10 to the power minus 12 watt per meter. So in this chapter, we not just learn the conversion between intensity to dB, we also learn that how we can combine sound to form a new dB. Never add dB, remember? Next, if we move the object further and further away, we can also estimate the intensity of the sound, okay, as it moves further away. I've placed a question, all right, at the below, which requires you to understand the whole lecture completely in order to solve this problem. All right, thanks for watching.